Hello class, this is a continuation on the application of the binomial probability and distributions formula. So in the previous video we saw three applications of how we might think of the application. In this video we're going to take a look at a slightly different way which we can think about these applications. Okay, let's get straight to it. So a factory has 8 machines and each have a 10% probability of breaking down during the day. What is the probability the factory has at least 2 working machines, and the assumption is it's working, so 2 working machines in one day. Okay, so if we were to try and apply this in the regular old way, where we're looking for working machines, okay, we would think of the binomial distribution, which I realized should have been 0.9. So we have 8 machines, so that's 8 repetitions. And if there's a 10% probability of breaking down, that would mean there's a 90% probability of working. But now the issue becomes is when it says at least 2 working machines. We can think of this, well, not think of it, is actually the probability of there being 2 machines exactly, plus 3 machines exactly, plus 4, plus 5, all the way up until 8 machines. So we would eventually, well not eventually, we will actually would have to apply this formula 1, 2, 3, 4, 5, 7 times and then add those probabilities. As you can see, that's rather cumbersome. So we can instead think of this in a different way. So instead of finding at least 2 working machines, this is equivalent to what is the probability that the factory has exactly 1 broken machine or faulty machine. So in this way, rather than thinking of it, think of the calculation such as this, we can instead think of it as x bin, binomial probability, 8 with 8 repetitions with a 10% of breaking down, and in this case we're just finding exactly 1. Okay. Whoops. So in this regard, all we're doing now is 8, choose 1, times 0.1 to the power of 1, times 0.9 to the power of 7. Okay, so now when we calculate this, let me just grab my calculator here. 8, choose 1, 0 times 0.1 to the power of 1 times 0.9 to the power of 7. This gives us, in decimals, 0.382 ... Well, if this is the probability of exactly 1 broken machine, okay, the rest, if we now do 1 minus the probability of exactly 1 broken machine, so 1 minus this, there's actually a 0.617 probability that there are at least 2 working machines, because it could be 2, 3, 4, 5, or 6, and etc. So binomial probabilities, rather than thinking of it as what we're looking for like this, we can instead think of it as working with the complement of that of the problem. Okay, so I hope that gave you a different look to binomial probabilities, and I hope that gave you an insight into the application of this formula, and hope to see you in the next video. Best of luck.